The objective of this video is to discuss all the necessary steps to build a multi-robot control system. The idea behind such a system is to coordinate multiple robots to perform a certain task. Today, these kind of systems are being developed and used in many industries and will be prevalent in the future. The challenge of these systems comes from the dependency of many interconnected parts. Our team implemented a simple project to investigate the necessary steps in implementing such system. At the most basic level, a multi-robot control system needs a robot to perform a task. Our robot drives autonomously using a combination of sensors and a gyroscope. 3 sensors on the bottom of the robot were used to follow physical world rules. These sensors were calibrated by centering the robot on a line and recording the output average of each sensor. The results were used to determine bounds for when each sensor was over a line. The combinations of values read determined the reaction of a robot. Once the robot was able to follow lines on the ground, a PID controller was implemented to allow the robot to accurately turn. Finally, April tags were positioned along the outside walls such that dividing the tag ID by 4 would determine a column or a row on the grid, and taking the mod 4 operation would determine the orientation of the robot. Our second step was to create a connection to integrate 2 systems together. A UDP wireless connection was created to exchange information between 2 programs that run simultaneously. The first program ran on the robot and used a socket to send data strings of the robot position in real time. The second program ran a server on a desktop computer that listened to a port for incoming data. Once data was received, the server parsed the message and used the information to control the movement of the robotic arm. Finally, the third step was to include the human aspect to our project. Our team created an interface for users to control the robot and play an interactive game. In this project, our team implemented all the necessary parts to create a multi-robot system. Our project can now be scaled to support a large number of robots performing together. The scalability is manageable because every new robot will be a copy of each other, with the same hardware and software. Our connection would be extended to a server that could control many robots at the same time, and would provide the abstraction for the user.